Live streaming is on.
Hey, Jace, how you doing?
Hey, Ben.
All right. Well, like I told the others, I had some health issues this week, and so I've done some research, and it's just gonna be slow doing this. Anyway, yeah. So hope you have fun at your daughter's birthday. Feel free to drop it anytime. And it's 6:31, and I'll go ahead and start. My name is Ben Francis, and so we're going to talk about a Linux utility called mdadm, which is the Linux software RAID. And it's a bit of an older tool. And if you were wanting to do protect your data, you would almost certainly do better with ZFS, as ZFS handles all the redundancy for you. But we had a request to hear about Linux software RAID, so let's do that. And there's I read a story today on YouTube about a guy that had a failure with his mdadm, his Linux software RAID array. Hold on. Hey, can somebody stop moving screaming? Goodness. All right. In a small house with 5 kids. Sorry. And this is the only Linux computer I have access to right now is in the noisiest part of the house. All right. Anyway, so yeah, somebody on YouTube had failures with their Linux software RAID, and so they used a program called JBOD. JBOD, which stands for just a bunch of disks, and apparently he likes it better than mdadm, and that's how he does it. So 2 alternatives to Linux software RAID. Why would you want to do RAID? Well, you're looking for redundancy. Linux software RAID is just taking. Well, there's a number of configurations, but the one we're going to do today is called mirroring, which is RAID 1. There is also there's a RAID 0 called Scary RAID, because if you set up your disk that way, your write speed doubles, but you if any one of the disks fails, then you lose the whole array and you lose all your data. So hence Scary RAID. RAID 1 just copies all the data from one disk to the other in a sync operation, and so if one drive fails, you can run in degraded mode, and your data will still be there until you replace the failed drive with the new one, and then the syncing operation will take a while depending on how much data you have, but eventually your second drive will catch up with the first one, and then you'll have a redundant copy of all the data on your first drive. Okay, so let me go and share my screen. Entire screen. Yeah, let's just go with that. And let's switch over. All right. Can you see my terminal?
Yes.
Okay.
Yep.
hide that. Okay. And what was I doing here? All right. So that is not a command I wanted to run. Okay. Okay. So what we have here is I am displaying. I'm in a utility called parted for partition editor. And well, here let me just get out of it. And because I'm already done with it. So if I do a block ID on the disk I have on the system right now, you'll see I've got this one drive that's got a Linux partition on it that has root on it, and then it's got this SDE2 is a swap partition. But then this one right here is my home is a separate partition for my home drive. Home drives are pretty important because that's where all your user data is. So what I thought would be a good thing to do would be to turn into a software RAID. And now that I think about it, might not be possible. Might have to blow it away, but there's not much data there anyway. I don't really care about it. So what I did is these are USB drives anyway. Not something you want to do in production because USB drives are slow. But anyway, yeah. So I have another USB drive right here, SDD1. It's got a partition, and if we do a parted -L on all these guys, we see. Here we go. This is the dev SDD, and all I did was copy the exact partition sectors from this drive right here, and you can see it starts at 24.7 gigs and ends at 119 gigabytes, and the size is 94.1. And I just copied that over here and made that partition. So RAID, the mdadm program can work with full disks or just partitions. And in this case, I just want an extra partition so I can make the RAID array. You want two partitions that are exactly the same, so that's why I copied the exact numbers. And so we got two partitions that are exactly the same, two different drives. One drive fails, then we're still good because we got good RAID array. Got a good backup disk. All right. So one is SDD1 and the other is SDE3 right there. So let's go ahead and do. We're already logged in as root. If you don't have mdadm, then the command to install it would be apt install. This is an Ubuntu system, and it should just come. It is just part of the Linux distribution. Oh, I guess not. Okay. All right. I do need to install it, which makes sense because you normally wouldn't want server tools on a desktop system. But I'm just doing a demo here, so that's fine. This is a new computer that I built with my kid just like a couple weeks ago, and so it should be pretty fast. Yep. All right, we're already done here. All right, so if we do a man page on mdadm, manage MD devices, aka Linux software RAID. MD. Anybody? I don't know what MD stands for. Does anybody?
I've assumed it was multiple disk administration. I also found out that in SUSE, it's included in the online updates repository.
Is it? Okay. All right. I'll buy that. This is the one we're going to use right now. Create the mdadm create mode. Create a new array, and then we need a couple.
So I just actually looked up the MD part, and its original name was Mirror Disk.
Ah, there you go. You guys are great.
Yep.
Picking me up.
I looked it up with the LDP, and they say it's multiple devices. So who knows?
Okay. And this is an old program.
Yeah.
I'm talking 2004, if not earlier. So if anybody knows the actual year this started, but yeah, we're talking kernel kernel 2.0 or 2.2, maybe earlier than that. I don't know. Yeah, we had a question. What I'm looking for is the parameter for specifying how many disks, and this is just a monster. This is just a monster. Man page. So there are, goodness. Oh, let me go backwards. Oh. Maybe it's devices. Oh man. Create. Okay. All right. Well, man pages aren't that helpful to me, so let's just do the old mdadm cheat sheet. Yep, there you go. Create, verbose, level. Yeah, okay. That's what we want. We want the level parameter is one of them. And we want create. We can, verbose is fine too. I like that. There's one other. I'm just gonna cover that part.
Ben.
Yes.
I think the device number is a
yes
-- RAID - devices and then equals and then a number.
Yeah, that's right. That's what I was looking for. Thank you. Yeah. Okay, so let me go back to the. Let's go back to the man page. Oops. Oh, I already pasted that. Level 1 is RAID 1. Yep, that's right. We want to give it this is the correct name. that you want to use, and then I'm sorry, who said that? What was the parameter? RAID devices?
Yeah, it was RAID dash devices
equals 2. Yeah, there we go.
And reduce 2.
All right, and so now we just got to tell them which devices we want. So dev std1 and dev SDE3. Okay, and let me check the command. So multiple disk 0. You will. This is the way you're always going to see devices show up as RAID. Unless you change them to something different. So I'll just stick with the standard. And let's let this fly and see what we get. Dev. All right, so we got an error, but that's okay. Errors are more fun than boring old successes. So cannot be open device read. Oh, it's busy. Okay, that's probably because I got it hanging. I got it right here. And let me close that. Close all the GUIs. And just for giggles, there we go. Now let's try it. This array is metadata at the start, may not be suitable as a boot device. Okay, we can ignore that. This is just a home directory. And it's warning us about dev SD3 appears containing the ext2 file system. So it doesn't say that it's going to blow it away, but rest assured, it's going to blow it away. So I'm going to lose my home directory. That's okay. This is just a something I was. This is just a Linux distro I had on a USB stick for playing around. So I'm going to go ahead and say yes. Ta-da! And there we go. This array is created and started. Well, so it started, but all we have right now is a mirrored block devices. Okay, so it's not mounted anywhere, and it's not, and we haven't put it in the logical volume management or anything like that. What a smart thing that I've seen some people do is they'll take a RAID array like this, and use that as the basis for logical volume management. So let's see. So you could do. Yeah. Okay. So this is I'm displaying using logical volume management. I'm displaying that I've got one volume in there right now, but I could also do. But if I wanted to add this RAID array into that as a logical volume, then I could do a pv create dev md0, and it should accept it as is and create it. Ta-da! So now we have a situation where I've got two logical. I don't have logical volumes yet, but I have two LVM volumes. One of them is mirrored, and the other one is not. So, we would have to keep that in mind and say, "Ooh, man, I better go back and make that other volume mirrored, or just keep it in mind so I don't put any super important data on here or on the old physical volume. So if I do a PV display, this PV display, this, right, this is P. There's the old one. And this is my kid's PC, so I give it crazy names. But there's our volume, and so we could go ahead and say, okay, now that I have a new volume, why I keep making that mistake? Display. All right, so I can display our volume groups with VG display. This command right here, and right now I only have one volume, and I can just keep that same volume name and just add this. I could add that whole array to this. I wonder if I could do that. It would be wrong to mix. It would be wrong to mix. A non-mirrored volume with a mirrored volume. So let's not do that. Let's do VG extend. Dev. Wait. We got to do the. Oh, Jace, are you still here? Help me out. I gotta.
It's been a while.
Are you wanting to create a new volume group or just extend the existing one?
That's right. That's what I was. Yeah, you got me. Thank you, Tristan.
Yeah. Sure thing.
So VG create, and then we'll call this one VG mirror, right? And then yeah, and then just the MD0. All right, volume group mirror successfully created. Okay. So now we have to add the disk that the RAID array that we created to this volume group. So we would VG extend, VG mirror with dev not
MD0?
Yeah, dev MD0. There we go. Uh-oh.
Yeah, you don't have to do that. It's already added.
Oh, it's already in there.
Yep. But you do have to create logical volumes on top of it.
Yeah, right. Okay. How did it know to put it in the right? Oh, because yeah, I told it to. Okay. I created a volume group named VG mirror with that. Yeah. Okay. All right. Gotcha. Thank you, Tristan. All right. So now we need an actual logical volume. So we do logical volume create, and here we do need the name parameter. I think it's dash name. And I always like to put LV in front whenever I name logical volumes, just so that I know it is a logical volume, and you'll see it that way in whenever you do a DF-H or something like that. So
Polish notation.
yeah, Polish notation. And we'll just give it no, we won't call it data. We'll call it home. Be a little bit more specific. And then we have to we have to give it a size, and that will be, and you can do, I think it's plus 100 percent. I'm sure I'm going to screw this up because there's big L and small L. But small L, I think you can do it this way, 100%, and then you have to name which volume group that you're using, which is VG Mirror. Yeah, VG Mirror. Oh, it's not. It's already not going to work. Oh goodness. Oh, I did find it. What am I doing? Okay.
Shirt.
Okay. Ryan. Be quiet. I'm in the meeting. All right. That is. Yeah, that's gonna do it. It'll give us a. Oh no, it didn't like it. It didn't like my extents. It was capital L. Does anybody know? Nope. Didn't like that either.
On the door.
Okay.
On the door.
Instead of 100%, let's just create a 10 gigabyte volume, just like that. You can do that with a capital L. Aha. Yes. All right. All right. So now we have a logical volume, and that's great. So now now we can actually create a file system on this logical volume. And let's just do, because we're a Linux user group, let's do ext4, but it could be XFS. I'm most familiar with this. And then the way you refer to logical volume is through the the Linux mapper utility, and you VG Mirror. There we go. So that, thank God for tab expansion. So we're just going to put an ext4 file system on this volume. Creating journal, running superblocks. Okay, it's done. All right. Now that we have the file system created, now we need to mount it somewhere. So let's create a mount point. Right there. Mount. Oh, it is the home. Well, let's just call it MD0. And now we can, if I could type, it would be great. All right. Device. Mapper. EG. Mirror LV home. 2 / yeah. Got an extra slash there. And there we go. So if we do a ls-l on that directory, we should, we don't have anything in there right now. So now we could actually test it to see if it actually does these great things it says it does. So all right, so there's a file. If we do, I'm just gonna actually, yeah, there we go. All right, yeah, there's our test file. And so now the thing to do would be to yank out one of the drives and see if it's still there. This is going to be an operation in itself. So I have to get behind the computer and do the terrible and yank one out. Oh, jeez.
Ben, is there a way
Yes.
to check for the RAID status? Like if it's rebuilding the RAID or setting it up initially, or in our case, once you yank it out, if it's degraded?
Yes. Wait. Oh, I thought it was MD. I thought it was MD stat.
So did I. I thought too.
I could have sworn it was MD stat. Let me go back to my. Let me go find a RAID cheat sheet.
Is it mdadm stat?
Oh, well, I don't know. RAID cheat sheet. All right, here we go. Ta-da.
I think it was right there at the top. It said something about cat proc MD stat.
Yes, yeah, that's right. That is, yes, that's one of the ways to do it. But I thought MD stat was one of the ways too. Okay,
MD detail, it said.
there we go. So yeah, all right. So let's try this. Let's resync. This is what I'm looking at right now.
Is it because once you set it up, it had to sync the drives, right?
Yeah,
Initial build of the RAID.
yeah. It's not done yet. So I better. Well, let's do a watch in this command. And yeah, it's getting bigger. See, this number right here is changing. And it's going to finish in 53 minutes. Why is it that doesn't make any sense to me? I mean, does anybody know why it's taking so long to build the array?
Well, you did say you had it on a flash memory stick, didn't you?
Yeah, but it's a fast one. It's USB 3.0.
Well, I think USB 3.0 is still slower than what is it? The SD protocol.
Yeah.
Not IDE. EIDE.
And the partitions were still like 94 gigs or something like that, so it's going to take a little bit of time. Sure.
Yeah, right. Yeah, I could have taken the opportunity at that point, knowing that I was going to blow away my data anyway, to just drop down to like 5 gigs.
So is one of them still yanked out?
No, I didn't yank it out. Justin saved me. So
now,
yeah.
When it's doing the initial RAID generation, am I correct? It's overwriting the file system that was already on that partition. In other words, it's no longer ext2.
Right. Well, I mean, it's ext4 right now because that's when I did the makefs. It created the.
It basically does a block level sync, right? If I remember correctly. And then, so the ext4 that you created was just the logical volume on the LVM on top of the whole thing.
Right. Yeah. So it's surprising, if it's doing all this. I mean, this is at way lower level than doing the file system, but but it went ahead and created it anyway. so I'm kind of surprised at this because this is low level stuff, and it appears that the low level stuff is not done yet, but it still created the file system anyway. It just goes to show you there's so much to learn about Linux every day that you can't learn it all. And honestly, this is my first time I ever done mdadm or software Linux raid. But it's a good exercise, and y'all might remember that Jim Salter was talking about RAID at one of our meetings, and I remember him talking about hardware RAID versus software RAID, and that if you go hardware RAID, you're in a world of hurt, because yes, your RAID array will be a little bit faster for the time that you have it, but then the RAID card is going to die 5 years later, and then you're going to be running around trying to find the manufacturer, and then the manufacturer is going to tell you that we don't make that RAID card anymore. And then you're stuck going to eBay trying to find this exact same card, and hoping that you're not buying somebody else's 5-year-old RAID card that they bricked. So yeah, almost always better to just go with software RAID, like this all the time, and then you'll never be in that situation.
Well, am I correct, or that the volume, the physical partitions that are in an MD don't have their own journaling? In other words, if you had data on the disk, it's not going to try to, or mdadm isn't going to let it try to fix the disk that was part of the MD0. So it's removed the journal components, metal components that you had on that partition before.
Yeah, that's correct, Bob. The it's just the simple 2 block devices getting synced by this tiny utility that its only job is to just make sure all the blocks on disk 1 are matching the blocks on disk 2. So can anybody think of what would be the problem if a cosmic ray comes from outer space and flips one of the bits on disk 1?
Well, you have to have some way of some type of forward error correction or detection in order to tell which disk it got flipped on, which is the good one, which is the bad one.
Right, and it can't know. So if a cosmic ray does flip a bit, and this does happen, the RAID array is going to say, "Oh, a bit flipped on RAID 1. Let me make sure that bit gets flipped on RAID 2. Or I mean, on the second disk as well." So you're effectively, so the RAID is going to effectively copy the bit rot to the second disk and make sure that your bit rot is complete.
And I purchased a NAS version of Linux for network attached storage a while back, and they actually used rsync to copy the stuff over to the second drive. And
Yep.
That sort of kind of I thought might be better, because you wouldn't get in a situation. It was like 12-hour wait time before they synced it.
Yeah, the reason for that, Daryl, is because rsync is an awesome copy tool. Don't get me wrong here. But what it has to do in order to be able to, I should explain it. rsync is a utility to copy or sync one file or directory to another, and it does do that great. But it's got to read. If you're rsyncing a 1 terabyte disk to another, terabyte disk, it's got to read every single bit of the 1 terabyte disk before it can copy it to the second one. That happens every time. If you flip just one bit on that first disk and then do an rsync, you're gonna be like, oh, this should be really fast. No, it's because it still has to read the entire disk to copy to the second one. So I think I'm doing that right, but and I'm remembering what Jim told us about that. Jim Salter. So the better solution is just to run ZFS. Because ZFS already knows which bits are supposed to be flipped and which aren't, and it will just do it in milliseconds for any changes. So, did I answer your question, Daryl?
Yes, sir, it did. Thank you.
Okay.
I may have been confused though. Does that mean that level 1 doesn't have any error detection or error correction, and you have to go to a different RAID level?
I don't believe that any of the RAIDs have actual error detection per se. They just make sure that redundancy is enforced across whatever you set it up as. If you have a mirror, you could have erroneous data on that mirror, and it's going to sync it, and it's going to make sure that that erroneous data is synced across to the other drive as well, because you always have a redundant duplicate. So if one hard drive fails, you still have that exact same data on the other one. Whether or not the data is valid or good or not, that's up to the actual file systems and programs and things, which is why people tend to go for ZFS and
Yes.
other file systems like that, because those have that, what you were talking about, like the forward-looking error correction, that kind of stuff.
Yes.
Because they do validate the data.
Mm-hmm.
Okay, so does that mean that level 1 then has a master and a slave? If the two
Correct.
bits are okay, thank you for the correction.
Yep.
Well, now RAID 5 and 6 also have a checksum, which is kind of like an error, but not quite.
Yeah, they have parity.
Parity, yes.
So the way I understand it from a hardware level, because I don't really do much of the software RAID, I typically did hardware, but I never did anything like major production where I would have to worry about if the RAID card went out or whatever. I never really had much serious data that I had to worry about. But RAID 1 is just straight up mirror. You just every bit gets synced to the second drive. So if one drive goes out, you still have one drive. 5, the way it works is basically a stripe, which is RAID 0. And what Ben said at the beginning, where yes, you would have extra speed because your data block, your byte would essentially get split into half, and one byte would go to one drive and the other byte would go to the other drive. So you would get faster throughput because you're writing more data to each drive at the same time, essentially double the data. But like Ben said, if any one of the drives failed, then both drives, whatever your RAID 0 pool was, you were dead on all the drives because your data was just hosed because it was split up like that. With RAID 5, you still got the RAID 0 split, but you have the checksumming, the parity on the third drive, on the non-even drive. So with RAID 5, you either had 3 drives or 5 drives, or you could go higher, but it was always odd. So one drive would be essentially like that shows, that little figure shows there, block 1A, the first bit or the first half of that byte. Block 1B would be the second part. I guess they also had 4 drives there. That doesn't look right. That looks more like RAID 10, but
Yeah.
RAID 5 has to be a minimum of 3. It can be a maximum of anything.
Yeah, but usually they would have. Well, yeah, that's true. Minimum of 3, maximum. Yeah, we would just usually do odd ones, but and then the parity bit would essentially be like you were saying, the checksum, where if less than half of the drives that you had in there failed, you had the parity bit plus the other half of those. So in this particular instance, you could, I think, still lose 2 drives and be okay out of the 4 that they show there. Definitely 1, for sure 1. You would be okay because if you lost the first column right there, drive 1, you have block 1B, block 1C, and the parity block 1, and it could rebuild the correct data of 1A, 1B, and 1C onto a replaced drive 1.
I follow that, and if I follow it correctly, with 4 devices, you could lose 1 device and still recover. In order to recover from 2 devices, you'd need a minimum of 5 devices, I believe.
Yeah. And so usually then you would go to, at that point with the amount of drives, you would go to a RAID level 10, where you could lose half of your drives essentially and be fine. So if you had 4 drives, well, you had a minimum.
I hate to disagree, but with RAID 5, you can only lose 1. With RAID 6, you can only lose 2. So as
with RAID 10, you could lose half.
Well, okay, so RAID 10 is a different beast altogether.
Yeah.
But as far as the parity, there's RAID 5, and then RAID 6 has 2 parities. So a RAID 6 array has to have a minimum of 4 physical disks, but you can lose 2.
Gotcha.
RAID 10 is a striped set of 3. Let's say there's 6 drives. It'd be 3 mirror sets that are striped, and you could lose half if they're on different sets of the mirrors. If you lost 2 off one mirror, you're screwed.
Yeah, that's correct. RAID 10 is what Oracle decided to use for by default. So because it's such a nice combination of speed and redundancy. So yeah, you can lose half the drives and still go on trucking.
Yeah, so the disadvantage between RAID 5 and RAID 10, typically what we would see is if you wanted as much redundancy as possible as far as being able to lose the most drives, you would want to go RAID 10, but you'd still have a little bit more space in your RAID array if you had 4 drives and RAID 5, because you had essentially 3 drives that were not really parity, and so you had a full 3 drives in that 4 drive set that can be used for your space. RAID 10, you would have essentially half of the amount of hard drives space across all the drives would be your total device that you could, carve up and partition and whatnot. And so you would get more space with a RAID level 5, but you had less redundancy versus a RAID 10.
Correct. And I've heard people that have had to rebuild a RAID 5 array say that it just wasn't worth it because it took so long to rebuild. Can anybody else confirm that? Yeah, here we go. It's restoring the data may take a day or longer. But I've seen that in data center. Remember, Jace? I mean, we had a large array, and
let's not bring that back up.
Now that's also with a 4 terabyte disk. If you look right above that.
Yeah.
So smaller drives back with like 320 gig drives and stuff that you'd build, years ago.
Right.
It wouldn't quite take that long, but it would still take a long time.
I'm really surprised how long this is taking. Look, I mean, we've been talking. This is still going to finish in 34 minutes. So, holy, okay. So our speed is
Yeah, I was gonna say theoretically the USB 3 and SATA are the same, about the same bandwidth, but your NAND disk on that thumb drive is probably it's not as fast as an SSD. If you were to put an
yeah,
SSD on the end of that 3.0 cable, then you'd get the same amount of speed.
yeah, yeah. So this is only going at about 23 megs per second, which is good for a flash drive, but terrible if you're if you're
I would be
boss is-
honestly curious to see what the speed would be because I haven't done this, but take an actual NVMe drive that's on the PCI bus and do a build onto another one, like a 1 terabyte and another 1 terabyte, and just I would just be curious to see what kind of speeds you'd get there.
There's a little device out now that you can pop a NVMe drive into a USB 3, like a little thumb drive enclosure. They're supposedly really fast. I've seen some people running Raspberry Pis on them, and
Nice.
so
I meant like they'll actually like straight into the PCI, but like an actual NVMe M.2 or not M.2, but M.2 key, but an actual NVMe slot on like a desktop motherboard. Have two of those on the same board, put two of them in there, set up a mirror, and just see how quickly it is because they'll both be connected to the PCI bus straight up. That would be interesting.
That's mainly what you get the advantage of RAID nowadays, is my understanding, is just the speed, if you want the speed from your disk. Otherwise, just use ZFS.
well, ZFS is pretty. I mean,
Yep.
I mean,
It's
as
a
far as
speed demon
redundancy, ZFS is mainly what people use now, but it's the advantage of RAID nowadays would be doubling your speed on your disk reads and writes.
yeah. And sometimes people put will have a scary RAID array of 2 disks, and say, "Ooh, I want to make this more redundant." So they buy 2 more disks, and what you can do is just turn that RAID 0 array into a RAID 10 just by adding 2 more disks. I think that's possible. I haven't done it myself, so it might be. Right. That's what I've read.
Would you lose any data that way?
No,
Like, would it
because
have
it's
to
just
create a whole new thing?
no. It would just because all it's got to do is copy the
Data over.
the one RAID 0 to the other set of disks. And let's see. What would the
I have a
what
question.
would yes? Go ahead.
And this just occurred to me today as you're presenting. But so LVM, the more disks you add, they're essentially stripes, right?
No, it's just pool. Like it'll just write on the first
Until it fills up.
yeah, until it fills up, and then it spills over into the next physical disk. However you carve it up, essentially.
Okay.
From what I understand.
Okay. All right. Well, then that answers that question. Thank you.
Yeah. Here's our logical volume that we created. This is the path, and you'll see paths for logical volumes in 2 ways. This is one way to refer to it. Just go by device, and then the volume group, and then the logical volume name. But you can also, if you cat the FS tab. Oh no, okay, that's not there. You'll see that's a lot of here, let me just grep for the mapper. Yeah, here we go. So this is another way to refer to the logical volume. And this right here is annoying. I don't, even though it's VG mirror, VG dash mirror, it has to do 2 dashes to recognize it. And I'm not sure why that is, but you will see that and you'll be like, huh? I thought it was dev VG mirror LV home. But it's just the way the Linux mapper works. Does anybody know why that is?
Presumably because if it only used a single hyphen, there'd be an ambiguity between whether the hyphen was a combination, a delimiter, in other words, of the LV volume and the LV group, or whether it was part of the name.
Yeah, that's it. Because, yes, that's correct, Bob. Thank you. This little dash right here is the delimiter between VG mirror as the volume group name and LV home as the logical volume name. So, yeah, thank you, Bob.
So far, all the RAID levels described use the checksum. Are there any that use something like Reed Solomon, i.e., a faster error detection algorithm?
I don't know about Reed Solomon. Have to get back with you on that one, Bob.
Just curious.
Yeah.
Since they it was mentioned that people are using RAID for speed rather than redundancy now. It might seem that I was wondering if they'd improve the speed on the checksum overhead.
Yeah, I don't know. Be interesting to find out. Let's do a watch. Let's check on our RAID array. Yeah, it's gonna finish in 27 minutes. So,
I have a question though that I don't know,
Yeah.
maybe Ben or Jace can answer. So one of the things I noticed is I know you can do the dev mapper, and that's typically where it is. But I also found that the actual volume group is straight up in /dev. So if you go /dev vg dash mapper, or I'm sorry, a RAID, whatever you called it, vg dash mirror. Is it just basically like a symlink or like a hard link?
let's check it out.
So you've got dev mapper. That's where it has
that
that
is.
terminology.
Yeah, I remember this. It's just a symlink to. It goes up a directory and goes to DM-2.
Okay.
And DM stands for disk mapper.
Okay, so what happens if you do the same thing but with /dev /vg dash mirror /lv dash home? So get rid of mapper, get rid of the vg dash, and then lv dash home. Yeah.
Same thing.
Same thing. It's just a shorthand notation.
It wants to go to the dev DM dash disk mapper 2.
Okay. I was just curious because when in my system I mounted it. I didn't use mapper. I just used straight up dev and then volume group / logical volume. So I was just curious what the difference was. Thanks.
Yeah, no problem.
Hey, Ben.
Okay. Yeah.
What about breaking the mirror?
Oh yeah. Well, I was gonna do that, and then we noticed that it wasn't done syncing.
Break it anyway.
All right. Yeah. Okay. All right. Let's do this. Let's tempt fate and go ahead and break a mirror that's already syncing. All right. So I'm gonna yank one of the drives out.
Will we get 7 years bad luck out of breaking a mirror?
Yeah, at least. I think you get. Yeah. That's it. So let me put a watch. Let's do a watch on MD stat while I do this. And then as soon as I pull it out, it's gonna bells are going to. Oh my god! I can't get this thing up. Okay, I got it out. It
Looks
has,
like it just froze on that.
it has
last
lost
block.
its mind. It has lost its mind. Well,
Yeah, the blocks aren't incrementing anymore.
yeah. The finish time is getting bigger, so it's like you're. Yeah, this is gonna go to infinity, and my speed is going down.
Took it back in.